Hello students, welcome to class. We're going to start off a video. You need to pull up your notebooks and be ready to answer the question, is this a physical or a chemical change? So watch the video.
In the now. Future, you have this moment. Future, in the now. Alright, ladies and gentlemen, so that's enough of that business. Put down whether you thought that was a physical or a chemical change and explain why. The next thing I'm going to do is we're going to go over what we're going to be talking about today. We'll be talking about the kinetic theory of matter, and we'll also be talking about conservation of mass or matter. That can be used interchangeably. So, kinetic theory of matter we've been talking about for a while, and we're also going to be doing a lab that explores this using balloons. As a mini experiment, I want you to imagine that you're holding a Hershey's Kiss. If you actually have a Hershey's Kiss or you have one from my class, go ahead and pull that out and hold that in your hand. Do not squish the Kiss. Don't ask me if you can eat it. Just hold on to it until the slide tells you you can stop holding on to it. Right now, I want you to record your observations about the Hershey's Kiss. Go ahead and just draw a drawing or describe what it looks like, feels like, smells like. And later, we'll be looking at that again. So the video is actually showing a physical change. It's nucleation. Nucleation is a process where particles of a gas become attached to a rough surface. So the Mentos actually have a rough surface. Now the flavor ones don't have the right type of surface for this. They actually have a slightly different surface. So you have to use the original Mentos for the Coke and Mentos reaction to occur. But if you go ahead and use the regular Mentos, they have a surface that allows nucleation to occur, which is a physical process whereby the gas bubbles form and become more and more prevalent. They build pressure within the Coke bottle, and that causes the explosion. Now the next few images are visual notes. Okay, so visual note taking is when you take an image to help you understand or explain a concept. In this case, we're looking at solid, gas, and liquid and how those change. So if you pause the video right here and draw this picture, it will really help you in your understanding. We're going to zoom into each of the vocabulary words in a moment. Okay, so now that you've gotten the drawing down, we're going to go ahead and look at the changes between gas and solid. So deposition is when a solid becomes, when a gas becomes a solid. When a gas becomes a solid, this is the same thing that happens in your car when you get up in the morning and you look out and you see your car has a sheet of ice on the windshield. The moisture in the air during the night gets so cold so quickly that it goes immediately from the gas form to the solid form, and this is called deposition. Sublimation is the opposite process. This is when a solid goes immediately into a gas, and you can find this often with dry ice. If you think back to Halloween, sublimation is one of those things that is happening to the dry ice that looks like the witch's brew with the cloud of CO2 coming off of the brick of ice. Freezing and melting are the two things that happen between a solid and a liquid. A liquid can freeze to become a solid, or a solid can melt to become a liquid. We don't often call it freezing, however, because when you have molten iron and you're trying to make a sword, you don't say that the iron is freezing as you make your sword. You usually say it's solidifying or that you're tempering it, so that we use other vocabulary most of the time. But one of the vocabulary words we might use would be freezing and melting. The last two vocabularies between gas and liquid. Condensation is when a gas becomes a liquid. You can see this if you set your kettle on underneath a surface. So if you take maybe a pan, like a cookie sheet, and hold it over your tea kettle, and you let that steam from the tea kettle go right up onto the pan, after a while you'll see it start to, the gas form of water become little drops of water on the bottom of that pan. And the other process that we have in the opposite direction is evaporation, when water goes into a gas form. And these are both words that you should have had from your climate section. So these are things that you should be familiar with already. This image right here is something you should definitely draw in your notebooks. This describes the process that is required for different states of matter to become another state. So in order for a solid to become a liquid, you have to add energy. That's where you see the plus E. That plus E indicates added energy. So as you go from left to right, during this whole process, there's energy being added. So something specific to note is that when a solid becomes a liquid and it starts to melt and become a liquid, the energy is continually being added, but the temperature is not rising. So if you think of up and down on this chart, up and down would be temperature. So you're adding more energy until the entire object is a liquid. Once you add enough energy, and it's all liquid, then the energy that you add actually causes a temperature increase until it reaches the point in which it becomes the next phase. So a liquid would then become a gas or a plasma. So if you look at your Hershey's Kiss right now, you'll notice that the bottom has melted a little. This is due to the heat transfer, or the heat energy of your hand being moved into the Hershey's Kiss. This process is an endothermic process for the Hershey's. When I say endothermic, I mean endo is into and thermic is heat, so heat is going into the Hershey's Kiss. For your hand, it's actually an exothermic process because heat is leaving your hand. Exo means to leave or exit, and thermic is, again, heat. So if you look at this chart and just add these two words with the arrows pointing in opposite directions, just like you have here to the chart that you had before, you'll have a great way to have both of those pieces of information put down in a visual way that'll help you remember your notes really easily. So again, an endothermic process is when you add heat to an object so that substance becomes warmer, for lack of a better word. And an exothermic process is when something is losing heat. Here we have an example of that exothermic process. Let me go ahead and restart this. So this is actually an exothermic process. The objects here are water molecules, and you see they're in the liquid phase right now. They're able to slide past each other. They're moving around. Every once in a while you see one of them that just kind of blasts through the screen, and that would be a gas particle. And here now they're becoming a solid. They're starting to be held in place. They're developing some weak bonds between one another. And as this process goes on, they become a solid. So as another example of this, we're going to go over to the slide over here, and I'm going to restart it a little bit. So this is the liquids in a, or this is an image of a gas becoming a liquid and then becoming a solid. So right now it's reached the liquid phase. And as it becomes a solid phase, you'll notice that a honeycomb shape appears as the bonds start connecting. It's not as clear as the last video is in demonstrating this exothermic process, but it does help with the general idea of the kinetic theory of energy, where all particles are in motion. So it's still in motion. You can see that it's still vibrating. You still have that piece. So the kinetic theory of matter, in a nutshell, is that matter is composed of small particles, all in random motion. Pause the video right here, write down this definition. It is extremely important, and you're going to need to know this. So again, the kinetic theory of matter states that matter is composed of small particles, all in random motion. Now, if you think about the conservation of matter, or mass, this is another definition. This is also on the test, so this is something you should probably remember just as heavily, and I want you to pause the video and write this down. Matter can neither be created nor destroyed. Okay, so that's really important for you to know. Matter can neither be created nor destroyed. This is just like earlier in the year when you learned about energy. Energy cannot be created or destroyed. The same thing applies here. So conservation of matter, matter can neither be created nor destroyed. So here's an image of something called hydroelectrolysis or electrohydrolysis. I can't remember which way you say it. Basic idea is you send electricity through water, through that compound, and as you send that electricity through there, it causes a chemical reaction. The chemical reaction is in fact that the hydrogen and the oxygen are separating from each other. So instead of H2O, you'll have H2 and O2. Here we have an image of that, or a equation showing that. So what this is it's water, H2O, split up and they become H2 and O2. Now because you can't have an oxygen off by itself, you have to have two water molecules in order to have it split up correctly. So if you had one water molecule, this chemical reaction would not occur. Isolating one water molecule would be a feat in of itself, but if you just had one water molecule, you could not separate it. Now, due to this feature of the elements, balancing these equations can get a little funny. So you see on the right-hand side it says 2H2O, meaning it has to have two water molecules, and on the left side of the equation it has 2H2. So that 2H2 means that there's two pairs of hydrogen, and then you have the pair of oxygen. So here is an explanation of that process and how to balance a chemical equation. We're not doing this in class. It's not required on the test. This is something that chemists do all the time, though. So I felt it was important that you were aware of it. If you're really interested in this, you can pause the video as we go through here and take a deeper look at each of these pieces. The images and the equation really do help clarify what's going on. So as you look at this, you can start to see that it requires some algebra skills. So if you haven't gotten into algebra yet, when you get to that point, you may revisit this and then have a better understanding of that process. Here's an example for those of you who want to go ahead and try playing with it. This is an unbalanced chemical equation, so it needs to be balanced. So if anybody can solve this, kudos to you. You can go ahead and look at this and try to balance the equation. Go ahead and pause the video, copy down those notes, and play with it. This is just a puzzle to solve. So in closing, I want you to, if you remember, I had you write down the definition for the law of conservation of mass and the kinetic theory of matter. I want you to have these written down again. And if you weren't in my class, everybody else turned in these definitions on a half sheet of paper. If you weren't in my class, when you come in and ask me what the assignments were, I'm actually going to want you to recite the definitions for both of these. So if you write down a piece of paper that you can read it from, that'll work.